So we were working on this. We need to go through the neighbors of the current block, and if we're outside, so if our current x coordinate is 0, then I want to break because we've hit the edge. Otherwise, I want to our open set, I want to push a new vector, which is x minus 1, y, and z. I'll have a look at it as soon as I'm done here. So now we just need 6 cases, and I love duplicating code like this. So if we're at size minus 1, we break, otherwise we push that one. Okay, actually, easier way to do this is not to generate all of these immediately, but just create these two and then copy paste them. Then we have for y and for z. And then we'll have plus 1 here and minus 1 here. And then we have plus 1 here and minus 1 here. Okay, so now we're moving around, we're counting these. So what we want to do when we're done with this, then if our open is empty, i.e. we've exhausted, walked around an entire component and we're done, this is a floater. So when we found a floater, what we want to do is we want to go through every block in our list of blocks that are this floater. We then want to set to 0 this block x, block y, and block z. Otherwise, if the list is still open, it's too big to be a floater, or we hit the edge of the chunk, and we're going to leave it. So that should, in theory, do floater removal. Could not match pair against tvec3. Blocks insert. So, initial problem is that the wonderful little I vector here does not have a less than operator. How about if we go for an unordered set? Unordered set. That means we should have a hash function instead. No member named unordered set. Please import it for me. Do we have a standard hash? No, we don't. Do I have a hashes.h here where I'm actually creating a hash function for it? So quickly switch over. There we go. So if I go and include hashes, it should know about that hash function. And we get a hashable set. Should be just as fine. Quickly switch over and see if we've gotten rid of some more floaters. Or if I've introduced an infinite loop. Cannot enlarge memory arrays. So I'm currently asking for more than 2 gigabytes of memory, which is a little bit on the large side. Well, that's interesting. So let's just quickly check that it is this code that's doing it. So we're just gonna refresh here. Yeah, that's the code that's doing it. So now the question is, why am I getting into such an amount of trouble from doing this? Okay, let's quickly try and do a little bit of a debug print here. So the number of blocks at this time, I need the IO stream, that's correct, is blocks.size. I'll put an end line here. Compile that. Switch over and refresh. Okay, looks like I've managed to kill Firefox completely. So just a moment. Get that running again. See if we can. There it is. And window capture here is this one. So let's just try a quick refresh here. So I'm getting a lot of blocks 1. That seems interesting. How many blocks do we have open? And do we ever finish this loop? Those are my main questions right now. We're gonna link and we're gonna switch over and see what happens. So yeah, we do exit that loop. But often, oh yeah, often we're just gonna break out of it immediately. Okay, this might be a good time to just check documentation that the queue is doing what I think it's doing. So we're looking at a standard queue. So push inserts an element at the end, and pop removes the first element, and front accesses the first element. So it is doing what I expect it to do. So that's a good thing. But what I might want to do over here is to move the popping of the current element until the very end here. So that if I hit one of these breaks immediately, then we're gonna assume then open is not gonna be empty, and we're not gonna remove that. So if we're crossing a chunk boundary, we're not gonna remove it. So let's try and refresh here. And we're gonna go over here and we're gonna refresh. I'm still slightly confused why I'm running out of memory, because this should not be using a lot of memory. So I want to see what happens when we're done here. So I'm going to print afterwards. Oh, and I'm not printing where I think I'm printing. I should be printing here. That explains a lot more of why I'm not getting the prints that I'm expecting. because it's this loop that's interesting. It's this one that has the complicated condition. But my thought is that I'm inserting a block every single iteration of this loop, so this should relatively quickly become false. So let's switch over. So we're just going to stop this. So, okay. One problem, which I hadn't kind of thought about, is that we're going to keep pushing an open block again and again. So it's probably cycling back and forth between like the same two and then just pushing on open. So what we want to do is we only want to do this if we don't have this position in our list of blocks already. So if blocks.count of this number is 0. So if we haven't seen the new, oh my god, I'm hitting all the wrong buttons today. So if we haven't seen the new position yet, we push it to be examined. And that's for every one of these. Apparently it's too long since I've done a breadth first search to be able to do it by heart. So that's a little bit depressing. So -1 here. And then on to the -y component. And positive y. Negative z. And positive z. No, I kind of prefer it actually as being else with an if inside, because it's not like this or this. It's not a case listing in the same sense. I prefer to do it this way in this case. Because this is very, very different case than this is. It's not like I'm trying to say this and this and this. It's not like an alternate switch. They're very different things I'm testing. So, let's try it out. So the script is still very, very slow. I'm going to give it a chance to continue. Okay, let's stop it and see what happens here. So it is completing every once in a while. So when it's done, it has 6 blocks and 0 open. Now it might just be that I'm outputting a lot of debug information, and that's why it's slow. So I'm going to be an optimist and say that's what's going on now. Let's try it without all the console spammage. Much better. But we're removing some interesting things. Especially because I'm still seeing floaters. I'm guessing we got some condition wrong here, because this looks interesting, to say the least. I'm really confused about what's going on here. It's an interesting design. Yeah, Regan, I kind of disagree with you there. I'm not keeping this. This looks weird. Very weird. So we're maintaining a queue of what's open right now, and then we have all the blocks that we've seen in this set, while the current list is not empty, and we still have room for more blocks. We take out the front one, we insert that. If we're at a quarter, we do stuff. Otherwise, we might push. So I've got all of these. Okay, officially, let's try positive X so that we actually seek towards positive X. Otherwise, I can see what's going on here. Because if we don't look in the we're not looking in the positive X direction, we're only looking in the negative X direction. And because of the direction we're scanning in, we can start removing stuff gradually, and this will happen. So yeah, let's just check that we've got positive on negative. Yeah, the rest look okay. Let's try that again then. So we're gonna switch over and refresh here. Well, that didn't do a lot. So, question is, what else am I getting wrong? Oh no, well, in a sense I am, but I'm looking through the entire while loop here before I decide whether I want to remove them. So I should walk the entire connected component of that block before I start removing it. Because this loop doesn't remove any blocks. I wait until afterwards. So I want to do this, I think. This is going to lag it a little bit again. Oh yeah, I'm doing something wrong. No doubt about that. The question is what? Let's just stop that script. So this is kind of interesting. So a case like this would remove 7 blocks because I have open 0. So open is empty. I'm getting like a lot of these blocks 7, open 0. Yeah, Regan, I have considered that it might be a good idea to sort of mention that people are asking things in chat, and mentioning that I should probably mention what I'm talking about before I just answer. But, well, tough to be on YouTube, I guess. No, I'll try and keep it in mind. I'm really getting a lot of these 7 blocks, 0 open, so that means I'm removing like 7 blocks at a time. And that seems... It would seem I either have a lot of 7 block floaters or something weird is going on with them. So we're just going to remove that again. Okay, I think I've got it this time. X, Y, and Z down here aren't the X, Y, and Z that I'm thinking they are. They're not the X, Y, and Z of the current block. They're my parameters that I've been given up here. So yeah, that's a thing. So yeah, let's try that instead. And that would also explain why I'm seeing a lot of 7s. Because then I'll like look at the center block and the 6 blocks around it. So yeah, that seems very plausible what's going on here. So we've still got floaters because, well, this technically isn't a floater. And something like this is probably straddling a chunk border somewhere. Is this a floater? Yes, it is. Possibly also a chunk border. That is just slightly annoying. So the question is, might it be interesting to draw chunk borders for a moment? And how do they interact with shaders? Probably not that well. Because that would also require passing through a fragment shader, I guess. And then we have this wonderful little thing here, which I'm calling is on a chunk border. So that's great. So am I even removing any floaters at the moment? Because I might not be. Let's just quickly... Yeah, Regan Lutz, as I was just talking about, it might be a good idea to add debug borders for my chunks. Thing is, lines and OpenGL don't like each other, basically. It's doable, but it's definitely not fun in any way. I mean, we could try it the really, really naive way. Let's give it a go. So in that case, what I need to do is I need to have an extra buffer, which we are going to call the line buffer. So our chunk render, where's the chunk render header file? Chunk render header file. So we have our vertex buffer data and so on. So what I'd like to do is I'd like to do a line buffer, and we have a line buffer data. So we're just going to quickly test if this works or not. So let's go back to the C++ file. There it is. So we have all of this fun stuff. which I'm going to get rid of in a moment. So we have all of these faces that we're adding and removing when we initialize our buffers. So what I would also like to do is to have our line buffer. So our line buffer is a different type of data. Where did I put? Starting to be unable to find this stuff. We're going to use GLM 4 vectors here because I just want the coordinates, the corners, essentially. That's not entirely true. So for our lines, this is going to be horrible, horrible stuff. We're going to give them a color. So we are going to have X, Y, and Z. Then we're going to have R, G, B, E, and A. Like that. This is going to be line vertex data. Going to do line vertex data here.
We've been waiting around for too long for something to show.
Okay.
Same old places and
So far, so
faces of
good.
people and nowhere to go.
What I'd like to do is, no matter what, down here,
We are better.
really need to get rid of some of this stuff because it's going to annoy me. I'm also going to kill off the index buffer because we're not using that.
Ready to go.
So don't generate a buffer for it. Let's get rid of this stuff because we've managed to migrate away from it.
We're leaving tonight.
There we go.
Away from these streets and the cold buzzing neon lights.
So our line buffer data. I want to push back
Struggling and striving.
a line from minus
We ain't gonna turn back this time. We'll just keep driving.
minus 8.5 float to 8.5 float.
On the steering wheel, worlds passing by outside.
Oh yeah, everything is so going to break in a moment.
Of the white lines in the
I want to do a line here and at minus 8.5 float. So this will be from the right upper to where we are at point 1 on the W. And we're going to go for point 1, 0, 0, and 1 for the color. I'm especially looking forward to the fact that I have to introduce a new material to make this work, because I need a new set of fragment and vertex shaders, and I have to switch the material during this. This is going to be so fun. So what I need to do is I want to make sure that this material is active here. Non-const function activate is called on const object. Activate should be, where's my GLES material? Okay, so a GLES material. Why is activate not const? It looks like it should be able to be const. So this material, activating it is a constant operation. Should be able to do that. Great. We were in the chunk renderer here. So after activating this material, I need to have another material. Which will be the line material.